coder is somebody who can just see a problem and just start coding, right? And that's certainly not me. So one of the problems that I've had, and probably still have when I'm faced with a really big problem, is being able to visualize the solution, being able to visualize the queries that need to, which queries are best for which, and how to tackle really big problems. So you got a 1,000-line SP, and you've got, and somebody says there's a bug in here, and I need you to fix it.
Right.
It's producing 3, and it should be producing 21, right?
Right.
So how do you go about learning to visualize stuff like that, and how do you tackle those big things? I mean, what's some really good advice for people that are struggling with that kind of thing?
Right. So I think the key point is to understand that it's not really magic. That you can't just, without any real knowledge and experience, you can't look at a problem and come up with a fantastic solution every time. So the point is to ultimately a querying problem is like pretty much a logical puzzle. That's part of why I like it so much. But anyway, you have kind of a mixture of more fundamental, techniques. So if you take, the 100 common types of querying problems and you break them into pieces, their fundamental components, you will find that there are certain techniques that when you break them down like Lego, that you can then go and mix them and create another solution, to handle another querying problem. So the point is identifying those more kind of, I would call them sub-problems, break the bigger problems into those smaller logical types of problems, and being able to come up with some solution for the first time, and then keep improving it, polishing it, improving it, and polishing and improving, and ultimately, it becomes easier and easier, but still challenging because always you get something new. So, take this common problem where you have this separated list of values and you need to break it into the individual elements, right? And if you need, for whatever reason, to handle it with T-SQL and not with .NET, because .NET for this particular task is the way to go, actually. But anyway, if you need to come up with a set-based solution for this, then you look at the separated list of values and you need to produce the individual elements. So first of all, instead of trying to come up with the final solution immediately, try to break it down into logical steps. So, for one, you know that if you have X number of elements within the string, you would need to produce X rows. So first of all, come up with a logical step that says, I need to generate copies of the original row. How many? As many as the number of elements. Later phase, you will figure out how to figure out how many elements there are, how to count how many.
So you have to get the data first, and then you can start
first
worrying
look
about
at it
manipulating.
before you start coding. Look at it, try to break it down into smaller steps, the problem itself. I need to first take the string and generate copies of the string. Second step, once I manage to generate copies, I need to then extract a different piece or a different element from each copy. When I'm done with this, maybe if it's part of the requirement, I also need to calculate the position of each element within the original array or within the original string. Now, dealing with the generation of copies, what's the fastest set-based technique to generate copies of a row? Okay, so it's a join, not a loop, obviously. So then let's come up with a way to take the original, string and somehow join with a table that has enough rows to represent the number of copies that you need. That's pretty much how you can handle or visualize, whatever you call visualizing the solution. And then once you figure out a way to generate copies efficiently, in another problem where you need to generate copies, you already know. You worked on this, you polished this particular technique, you improved it. So also there's a whole bunch of problems that you can handle with the row numbers, the very, very powerful row numbers that were added in SQL Server 2005. And in general, the concept of the overclose that allows us to handle things in particular logical order, handle it within partitions if we need, frame the window, and so on and so on. So, there's so many types of problems where you can use those ranking calculations, as part of the solution, but, maybe you don't see it until first time you managed to figure out when you saw how to handle this particular step with the ranking calculation. And then a different kind of problem, you can use the same technique with some variations. If you're familiar with the problems called gaps and islands, where you need to figure out what are the ranges of missing values within a sequence versus the ranges of existing values. So there are amazing, amazing solutions that are based on raw numbers. They're not that intuitive, let's say. I mean, it's not something that I would say that an average programmer would look at this and never thought about how to use ranking calculations for this purpose. But once you see it, you get the point, you get the idea, then you can actually use similar concepts in completely different types of problems that also deal with sequences, but I don't know, variations, maybe with temporal data or whatever. So I think it's more about the ability to solve querying problems elegantly and efficiently is about experience. You keep working on problems, you break them into steps, you solve each step. Most likely the first few times won't be that efficient, but then the thing is you keep, going back to those and improving, and the more you have, it's like having a bigger vocabulary, a bigger toolbox, whatever you want to call it.
So on that same note, then, what is a good recommendation for building up to that point? Just of course working on problems, but in addition to that, I mean, reading books, you get a lot out of that. But is there anything additional? Are there repetition? Like a weight routine? Are there repetitions? Do you do a lot of logic puzzles? I know you include logic puzzles in your book.
Yeah, logic puzzles I find is a key because, as I said, the SQL problems are very, very much in their heart logic problems. So, and logic, even though some people have it within them, it's kind of part of their natural abilities, it is something that you can improve.
Yes.
Walking.
I certainly hope so.
Oh yeah, it's something that you can definitely improve. So the point is, in some cases, it's like mathematical proofs. You need to do it yourself.
Right.
If you don't, if you just read other people's proofs, you will never get better.
You never learn the process.
So it has to be kind of a combination of looking at other people's solutions, always first trying your own. Always first trying your own, coming up with the best you can, then looking at other people's solution and see if you can, and this is how you can absorb much more, because once you try to work on it, then all kinds of processes already ran through your brain. So things that you would not be able to really absorb or recognize if you didn't try to work on it yourself. So I would say this: you always work on your own solution. Once you come up with something, whatever is the best that you can, now start looking at others. And this way you learn another technique, and it becomes a more and more kind of natural thing, I think. So yeah, that's.
And you were actually doing that when you were going through a problem about 3 or 4 months. No, about 3 or 4 months ago. Remember, you did a video on that when you said, "Here's a solution I've got, and then here's a solution somebody else."
Yeah, I remember that.
Something I found on the internet, and then she found one in your book.
Right.
And then she said, and she presented all 3 of them and said,
Yeah, at the time it was kind of
one.
embarrassing because I had gone through and done the first part of the video, and there was my solution, and then I went and found a better one, and I'm like, oh well. And you kind of you almost feel like a failure, but I think there needs to be a change in thinking because, this was my solution, and now I have worked through it myself, and now I can go and see that someone else has a better solution and I can incorporate that.
Yeah, always like this, you can look at things negatively or positively, I guess, but here it's really, as long as you put the effort,
right.
And as long as you're, went through all of those processes, looking at other people's solution can really be rewarding by itself. This is something I would not think about myself, or maybe you would, but you just didn't.
Yeah.
Didn't. I can give you an example, and this part of what makes it so exciting, I think, because if everything was so trivial, if it was so straightforward, so it would be boring.
Yeah.
They wouldn't need you to go all the way around the world and teach all the time, huh?
And I can give you an example that there was this kind of problem that deals with temporal data, where you need the concept of per user license, where the license is based on how many concurrent sessions you have at most.
Mm-hmm, mm-hmm.
So say that you operate on data that represents connections that users made to applications, and for each application every month you need to calculate billing information based on what was the maximum number of concurrent sessions connected to each application. So it's somehow figuring out within the period where there were many sessions, what's the number of sessions that were active at most at the same point in time. This is quite an interesting problem to solve efficiently. And I can tell you that for quite a few years, I would say probably over 5 years, this is one of the uncommon cases where I thought that the only reasonable solution in terms of performance was based on cursors. even though by far the majority of problems are usually best solved with set-based queries, there are here and there minority that, the way SQL servers optimize handles those. So the best set-based solution that I had so far was a solution with the quadratic complexity, where you increase the number of rows by a factor of f, runtime increases by a factor of f squared. So, unless you're dealing with tiny table, it just never finishes. And a cursor solution that I had did this in linear complexity, so just two passes over the data. And then a few months ago, I was in the UK delivering a class, and I gave this as an exercise to students. I wanted to show a case where, even though the recommendation is stick to set-based solutions, here and there. And one student came up with some idea. He didn't develop it, but he came up with an idea that thought that would work, and then eventually I came up with a solution based on his insight that had linear complexity. But still, if you have a million rows in the table, for each row, the plan for this particular solution needed a seek operation in an index, right? So it was linear complexity, so you double the number of rows is double the time, but still there is some cost associated with each row. So I published a couple of articles just last month and this month talking about how interesting it is that after several good years, suddenly something completely new, type of thinking came up that led to this better performing solution. And then one of the readers sends me a solution is even faster than this one. One is based on row numbers. You would thought that this would be impossible, but yeah, this guy called Ben Flanagan sent this solution. Is very, very similar to a technique that I use for islands problems, but never thought of being able to apply to this particular one.
I love that. I love that.
One pass over the data.
Wow.
Not linear complexity, but not far from being quadratic. Amazing, beautiful solution that uses set-based query. Amazing. So this gives you a lot of hope. That problems that you're sure that currently there's no good solution. It's just that you don't see it yet.
Yeah.
So it keeps things interesting, that it's worthwhile, put more time, revisit problems. If now you can see the solution, leave it, come back to it later, after you maybe, learned a couple of new things from people, techniques that you never thought about, So, yeah.
I know, I've been
Keeps
amazed
things
at some of the solutions I've seen people come up with that were just clearly using things in ways they weren't meant to be used for, and that's just... I just love that. That's fabulous.
Yeah. It's amazing.
Switching just a little bit. You clearly didn't, get out of high school and pick up a SQL book and then start teaching. I'm sure that you had quite a few years as a coder yourself, perhaps, right?
So actually,
so what's your I know nothing about your background.
Yeah, so I started actually with computers generally, not specifically SQL in the army, and my first exposure to SQL was part of a programming class we had there was SQL class. This was with mainframes, but this was my first time that I saw a SQL query. I really loved it back then, but still didn't think of making it my focus. So I worked with I was an operator for AS400 for the service in the army, and
Be careful, you're going to age yourself.
Well, this was until 92.
Okay.
And then I started working in the main beer factory in Israel. Also there, I started actually working.
Beer factory?
Beer factory,
okay.
Yeah. Yeah, it was great job. My wife actually, I knew her before. I met her in the army, but she also joined there and also worked with there for a few years. You get 2 free cases of beer every month.
So between the two,
that's the salary. So,
yeah, but the smell whenever you get to the factory, for my wife it gave her heartburns, but I like the smell.
It goes
Anyway.
through cycles, doesn't it? No, I mean
Beer or
because like
heartburn?
the smell different during the different fermentation cycles. The smell in the air goes through different
Yeah,
cycles.
I guess I'm not a big expert with beer, but yeah. So anyway, there I started working as an S400 operator, but then at some point I started dealing with the data analysis stuff. So I would create processes that suck the data from the AS400s into PC databases, and then on top also do all kinds of analysis, costing, sales analysis, all kinds of things like this, and then at some point we brought Panorama, which is the technology that Microsoft later purchased from this Israeli company called Panorama, that eventually became all-up services in SQL Server, and at some point later they switched the name to analysis services. But anyway, I worked with the original technology that now we have in SQL Server analysis services. So I built cubes. My first cube had to do with beer products. It was quite interesting.
Nice.
So yeah, all kinds of data analysis related activities. So this is where I started dealing more with databases and with data in general, with the SQL. And then at a later point, I started also, at some part, I also did some networking related projects, not really related to data. So there was a period where I ran projects that did network migrations, from older versions to newer versions. Like from back then, it was from Windows 3, 11, whatever, to 95 with NT servers and so on. And then later, I came back to the data-related stuff, where I started focusing on SQL and specifically SQL Server, and also on teaching. And that's where I found that this is the part that I really love to do best.
So we've got 5 minutes. I just
probably
found
about
out.
3 now.
About 3 now. I got 2 more questions, and we're going to try to hit these rapid fire. I want to ask something that hopefully will inspire lesser coders to hang in there.
Hey!
What's the biggest mistake that Itzik Ben-Gan has ever made in a production environment?
I would say, I can mention a couple. Once, this was actually back then in the army, when I was talking with my wife over the phone, who is now my wife. Back then she was just my girlfriend, but I was talking with her over the phone, and this is a central computer room where a bunch of branches from army units spread all over the country are connected to this central environment. And sometimes we would bring down the system on purpose to do some maintenance activities, whatever. But this particular time I was talking with her over the phone. I was completely distracted. I was sitting on the main console, and I typed the command power down system *emit, which brings the whole central machine down. And people started calling. And I said, we're doing backup, and they said, okay. Okay.
But you went back up.
Well, it took half an hour. The system takes like half an hour to come back. But
So
yeah.
what's 2?
Number 2 is actually also in the same unit. This was a certain database, kind of a proprietary database that they use in the army, and someone wanted me to delete a specific database. And in that product, the databases are actually made of a bunch of files that all start with certain initials, and then the number of the database. So it was MH whatever, and then the number, say database 13 would be MH13 and some extensions. They said if you could delete database 13, and I say no problem, and I say del mh star instead of the 13 and then wiped out their entire database. And we tried all kinds of tools to recover, there's all those tools that can recover, but I did all kinds of other mistakes on top to make sure that the data was unrecoverable. And this was just a favor. It wasn't even my unit. It was just a favor that they did because they didn't know how to delete the database. So
I bet
well, that's how you do
okay,
it.
so last question. I'd love to delve into that more, but okay. So you're on the standards committee that decided that SQL was pronounced SQL, and
not
there
SQL.
was
not SQL, yeah.
Yeah, a load of discussion around that. In 60 seconds, can you tell us what the discussions were? What kinds of things came up in the discussions about what to call it? What were the big arguments on the table?
I'm really not sure what were the arguments. I do know that originally they wanted it to be named SQL, not really SQL. The original name of the language was SQL for structured English. The E part was for English,
right.
Query language. But then apparently there was a trademark dispute with some airline company that owned the trademark for SQL, and they had to change the name to SQL. So in fact, when today you pronounce it as SQL, it's wrong.
Right.
is wrong. Even though people,
And
including
nobody
myself,
says SQL Server.
yeah, it's just more fluent kind of way. But this was the history why they had to change it from the original SQL name
I
to
see.
SQL.
Okay. Well, we're being kicked out of the room.
Yeah. Okay.
That's it. Thanks a lot.
Well, thank you for having
Thank
me.
you very much.
Very much.
Excellent. And we'll send you the link so you can post
Okay.
it and all of that.
All right.
Excellent. And I will stop the recording in our